Good evening, everybody, and welcome to the 9th annual DifferenceMaker for the Francis College of Engineering prototyping competition. So I'm Jim Sherwood. I'm the Dean of the College of Engineering. So many of the students probably didn't know that as I walked up to introduce myself. So this competition is here to promote and recognize innovation within the college. And this year we received 22 applications. Tonight, you're going to hear from the top 6 teams who were chosen earlier this evening to compete for the $5,500 in prizes. So each, excuse me. So each team's going to have 5 minutes to present their project, and it's going to be followed once again by 5 minutes of question and answer from the judges. So after all 6 teams have presented, we will have a 30-minute intermission while the judges determine the first place, second place, and third place winners. And around 8:30, the judges will return and the winners will be announced. So we know that the projects that were presented this evening, some of these may go on to do bigger and better things. For example, we have Invisaware. That's the safety jewelry application that won the prototyping competition and the DifferenceMaker Innovative Technology Solution Award. This was about 5-6 years ago. With their funding and additional DifferenceMaker support, they have reached over $1 million in sales. They have office space in Lowell. They have 15 people working for them. And they've been featured on the news. I remember seeing that news story where this woman was in a car wreck. She was unable to reach her cell phone, but she was able to reach the Invisaware jewelry that she was wearing and able to call for help. So that's an amazing story and just the amazing difference that this has made. So I guess I just said right there, DifferenceMaker, in my little description. So they've gone on to partner with ADT, and then they've been on QVC also for selling their product. So a recent winner, excuse me, of DifferenceMaker's Idea Challenge and the Francis College of Engineering Prototype Competition, Ambulatory Innovations, pitched and won regional competition against Harvard, MIT, BU, and Northeastern. Additionally, they are currently working with UMass Lowell's Nerve Center to develop the test prototype of a mat to help physical therapists treat their patients by simulating outdoor terrain. Maybe you've seen these and saw this project in the past. They have these little tiles that they can put together and they can simulate different terrains with that inside the home in a safe condition. Lastly, they have several patents pending to protect their product. So we want to acknowledge all the effort that our participants have put in for this evening. Let's give them a round of applause. So I'd like to thank everyone who has joined us this evening. Before we get started, I'd like to recognize all the DifferenceMaker faculty fellows who act as ambassadors for the DifferenceMaker within their colleges and departments. These faculty members help mentor the student teams and prepare them for competitions like this one. So I want to give a special thanks to the College of Engineering faculty fellows, Carter Keogh. Carter, I know you're here. And right beside her is Khalil Wallowitz. I might have said this last year, and I'll say it again this year. So Carter and Khalil started at the same time, and as I was interviewing them and working hard to hire them to come here and reel them in, after they signed on the dotted line, I said, I have an idea. I'd like for you guys to help out with SWE, and there's also DifferenceMakers. So here's what SWE is, here's what DifferenceMakers is, and pick as to one would like to do this, one would like to do that. And of course the answer came back, we want to do both. So anyhow, they're helping out in multiple ways here, serving the university. So let's give them a round of applause. So I'd also like to thank the DifferenceMakers team. Holly Lalos, who can't be here, she's out on parental leave. She had, I understand, a baby boy at the beginning of November. And David Baudolero, the RISC Fellow. If you want to stand up. For collaborating with us here tonight, David worked diligently with the teams over there to tally the scores, as well as Sally Washburn, Senior Director of Development for recruiting these amazing judges that we have. And once again, I want to thank Paulette for organizing this. And thank you to Provost Joe Hartman, as well as Chancellor Julie Chen for their support of DifferenceMaker. And I want to thank the preliminary judges. The names will be flashed up here in just a moment. So Jim Biggins, better put my reading glasses on. Bob Finland, Joe Halsey, Beth Haskell, Ken Porton, Dave, Janisek, thank you, Sally. I should have practiced before this. Joe Lane, Bill Percivalli, and Lee Sharrock. Thank you. Did any of preliminary judges stick around? Okay. And then now for the tonight's judges for the final round, we have Mike Ryder. Mike, please stand up. He's Vice President of Engineering. And we have Chad LaFrance, Director of at Texas Instruments. And he's also the sponsor of our second prize tonight. Then we have Mark Saab. And he's the founding trustee of the Saab Family Foundation. And last but not least, we have Greg Sidney. Want to stand up there? Managing Director of Tri-Capital and Companies. So, now over the next hour and a little bit, since we have 6 teams tonight, you will hear from our 6 student teams. Each team, as I already said, is going to have 5 minutes to do their pitch, 5 minutes for Q&A with the judges. After the pitches, there'll be a 30-minute intermission while the judges deliberate. After that, the awards will be announced. $2,500 for the first place team, and $1,500, $1,000, and $500 award for the People's Choice. So I hope you voted on the People's Choice Award. Please keep in mind that the first place winner will automatically advance into the DifferenceMaker preliminary pitch-off this spring for a chance to win a portion of $50,000 in funding. This is a bonus to what they're getting tonight. I wish luck to each of the teams this evening. Keep in mind that there are microphones on the podium, a wireless microphone right here, and a laser pointer for you to use. David Volatero, right here, is going to alert the 1-minute warning mark when time is up. Now for the finalist teams and their pitches. So in no specific order, the finalists are, and do we have a drum roll? Or? Thank you. Solar Sales. Philomil. Catnap. Packstrap. Reband. And Physical Engineers. Congratulations. So we'll call. Okay. All right. Solar Sales. Come on down.
Can you hear me? Okay, hi everyone. This is Team Solar Sales. I'm Quinn Long Lang. I'm the team captain. My partner, Alap Fidel, couldn't be here today. He has a workplace commitment. And I'd like to thank these people who helped me get here. Okay, how do I switch to the next slide?
There's a clicker right there. There's a remote control.
Okay. Okay, so this entire project starts with a conversation I had with Gabriel Colvero, who is the head of the UML Drone Club. Gabriel Colvero has been working with drones and building them for a few years now, and he was invited to a military conference where military contractors were selling their product to government agencies. And at that conference, he saw that a lot of these drones had almost the exact same physical capabilities as the ones we had been producing. However, they just have a plastic cover on them that was really shiny, a thermal camera, and then suddenly cost $10,000 to $20,000 more than the ones we had been building. So this kind of fit in line with my own assumption. I've been building drones for a few years, and I've been seeing these things on the market because I went to the military that would cost way more than they should be for their capabilities. So we just started looking for a problem to solve, thinking that we might be able to beat the competition. Here's one problem we found. $2 billion are spent by the National Coast Guard every single year on the mission of trying to stop drug trafficking through the American maritime. Unfortunately, they're pretty bad at it. 90% of all drugs that go through this land, they get through successfully. Only 10% are actually stopped by the National Coast Guard. This has been linked to, as stated by the U.S. Naval Institute, the inherent difficulty of patrolling such vast areas of land, 7 million square miles. Now we get to another issue. At the U.S. southern border, a lot of migrants are being forced into the Sonoran Desert as they try to avoid urban border crossings, which are heavily patrolled and very secure. So instead they go through the desert and they end up dying because they miscalculate the risk. This is like hundreds of bodies are found every single year, so the humanitarian crisis going on. Next slide. Okay, so the opportunity comes from this. Congress is keenly interested in using UAVs for this platform because UAVs present the perfect solution for this problem. What can fly autonomously, can cover vast areas of land, and therefore decrease the price. Unfortunately, according to a 2004 to 2010 Homeland Security report, Congress found that UAVs have a high cost of operating twice that of manned aircraft, which doesn't quite make sense. The opportunity continues when we see that National Coast Guard and also Customs Border Patrol are actually still interested. In the 2023 budget, they're putting $309 million into developing new technologies. UAV took up $75 million in that budget. Anyways, here are competitors. Okay, this plane right here can fly for 2 to 4 hours, can cover 200 miles in a single charge. This plane right here can fly for 10 to 14 hours, can cover about 1,000 miles in a single charge. Pretty cool. They have cameras on them. But this one costs $100,000. This one costs $250,000. These prices are astronomical. Now, our solution is to build a solar-powered plane that would utilize the power of the sun, allowing it to basically become something called a pseudo-satellite. It can just kind of stay there once you launch it for days, potentially weeks on end. And it's completely autonomous. It just flies routes. We use open source hardware and components that are commercially available to hobbyists, and we can meet market demand. This is an example. This is not mine. This belongs to the UML Drone Club of such a thing. This plane right here costs $400 and flew 30 miles. It has an Ardu Pilot flight controller that allows it to fly completely autonomously, and several video and telemetry systems on it. So we've got resources available, the UML wind tunnel, the lovely professors here, and we need money in order to build a prototype so we can take it to the National Coast Guard down in Boston. Oh, crap, there's a timer. So we need to take it to the National Coast Guard. We need to take it to, once we go to the Coast Guard and get confirmation that it works or it's useful, we can then take it to investors, and hopefully we can start building a product. So this entire thing hinges around the fact that the current contracting system in the American government is very heavily monopolized among a few key players. But recently, things have been changing. In 2017, a company was founded called Andro Technologies, which was one of the first companies to reach multi-billion-dollar status within the contracting sphere, going toe-to-toe with key players like Lockheed Martin and Boeing. This basically opened the eyes of investors who basically said, hey, wait, we can actually invest in companies and start making money in this, meaning a huge wave of investment is going.
So I'll just ask one quick question. Your first customer is going to be military or commercial customers?
We want to go for the non-military agencies like National Coast Guard or Customs Border Patrol, but these are all under the specter of the Department of Defense. So once you go into one, I believe there should be avenues to go into others.
What do you think the product that you're trying to make should cost?
We think that our product should cost below $10,000. There have been people who have made this product, like something similar to it, they just haven't taken it to market. An example is a 2015 research paper published by some Swiss people. Theirs cost like $3,000 or $5,000. Our $10,000 number is taking into account that maybe we'll have to add some super expensive camera, which we don't think will be $10,000 is the highest.
So you're saying you think you can put solar panels on something that big that will power it?
Will not be this big. The actual plane will have to have a wingspan of about 8 feet in order to get enough surface area, but it can be done. In fact, it has been done by a lot of hobbyists, surprisingly. They just have never been in an opportunity to take it to market, which we are with this conference.
Now, are you anticipate what is your shelf life in regards to the batteries or the solar?
So our shelf life should be in the years. Each battery can go through several thousand charge cycles, and the solar panels only degrade by a few percent every single year. So this shelf life should be really high.
But how long the charge you anticipate? So once the drone is out there, how long?
How long can it remain?
Yeah.
So this is something we want to develop further. The current world record for a sub 50-pound system, which our system will probably weigh less than 50 pounds, is 81 continuous hours. But this was by a research paper that just ran out of funding. They were planning on going on a mission across the entire Atlantic Ocean with a solar-powered plane. They just lost funding before they could do it. In fact, their prototype should have been capable for more than 81 hours. They just called the test at that rate. So our length, we want to get to maybe a week. A week is starting point, and then after that we can get to the month range. But getting past the month range is pretty difficult.
Now, you anticipate, let's say you get to a week or a month, whatever, we anticipate bringing this drone back into recharge, or is automatically going to be recharged by the solar energy?
So a week, should I interrupt? A week to a month means there's no battery nor diesel engine nor kerosene thing that has enough energy to keep anything up for a month. During that time, it would be recharging from the sun every single day and then using its power reserves at night. The limit for a week or a month is mostly just how much damage will it sustain from wind. Will it start raining a month from now, and that will make it so we can no longer fly. Or we can just tell these things to fly away from the storm clouds, which could extend their life, but there's still some sort of limit that comes to maintenance. But we don't know what that is yet because we don't have a prototype.
Do you know what the life expectations are of the competition? So the $100,000 drone that you saw, do they expect those to last years, or do they expect them to be kind of disposable?
I don't know for those drones, but from Gabriel, who is the head of the UML Drone Club, he noted that at this convention, a lot of these drones had battery packs associated with them that had to be thrown out after 20 cycles of use for some unknown reason. So that's the only thing I know about this kind of drone. I estimate they should be capable of a long time, but they're not going to be advertised or used that way.
And the $10,000, was that the cost of the product, or is that what you would sell it for?
That is the high-end cost of the product. Even because the market is so overvalued, we can then sell for $20,000 with a 50% profit margin and still beat the competition by a factor of 5.
Okay, we're going to circle back to Phil and Mel. Their presentation file is not cooperating with us right now. So we will go to Cat now.
Hello everyone.
It's in the end.
So my name is Fritz. This is Katnava, as you already know. This is the rest of my teammate, and they're gonna introduce themselves.
Well, my name is Max.
My name is Raj.
Mike.
So basically, our project is we're working on cured asthma attack within children from the age of 0 to 12. That's our focus. Probably, we're trying to find a way to improve quality of sleep. At the same time, reduce sleep disruption. That's what we're working on.
Right. So the main problem that we're kind of focusing on here is nocturnal asthma. Now, this is a big problem, especially, because, asthma attacks in general, what ends up happening is the airways get inflamed. And you can inhale, but you cannot exhale carbon dioxide. And this is a very, very big problem in minors, toddlers, and adolescents from ages 0 to 12, because they cannot, if you can't exhale carbon dioxide, you're in a state of shock. Happens at random moments in the night, they'll wake up and they can't cry for help, to their mom. They're very, very reliant on their parents. Mom, dad, help, I'm dying, they can't say anything, they're in a state of shock. So what we are looking to do is we haven't made a working prototype yet, but we're currently making a device that would sense oxygen levels throughout the bloodstream, and if it goes under a certain point, it will alert the parents throughout an alarm, which they'll come running into the room and they'll administer medication to the child.
Okay, so just to understand how the gravity of the problem, just in the United States, over 25 million people have asthma, and from this 25 million, 40% wake up every single night from nocturnal asthma. Over 2 million children around from 0 to 11 suffer from this problem. It's a lot of people that don't have an actual cure, because asthma doesn't have a cure. They have just treatments. We have inhalers, we have nebulizers, we have a singular that is medication that it's not very applicable for children because of their digestive system and because the toddlers they just can't chew. So what we're trying to do is explore this treatment that we have and connect the solution to the treatment. The market of it on the whole world is around $24.8 billion, and it's increasing 2.6% a year, expecting in 2027 of more than $30 billion on this size. Therefore, we created this device. It's basically a sensor of oxygen that will go on their toe. Why their toe? The best places to check the oxygen level are in the fingers, the forehead, the earlobe, the toe, and the wrist. That is not as precise. We chose the toe because wirelessly can you move on. The children, they can move. So we chose the toe, we connect the toe. It is one of the most best precise on their body. And this will send information to an ankle band that will interpret the information coming from the sensor and will check, the oxygen is lower than it's supposed to be. It will send an alert to their parents on their cell phones, smartwatches. Everyone today have an Alexa, a HomePad, so they can wake up and come and help the children. We're trying to create a faster way to deal with the problem, so they can deal with the brain come down, just come here, come down, deal with the problem.
As for the resources, this not working prototype only took a couple of dollars to make. For the short term, we're looking for around $2,000. That would help make a real working prototype as well as doing our first initial studies. And for the long term, we're estimating around 1.5 million. This would be for to get approved by the FDA, research, testing, and advertising, as well as building a company.
I just want to add one thing for the competition in the markets. I just wanted to add that the gum is a choking hazard. There's currently no actual thing in the market that is advertised towards toddlers. the one thing that we have right now is actually it's stuck out.
Now, you mentioned this particular product with the FDA. So are you familiar with a 510K?
No.
Okay, so that's usually where a product like this will get through the 510K. Did you also consider notifying the physician instead, automatically, or a nurse automatically?
So we have considered, branching out with this because we have a solid foundation, I think, for this. I think the sky's the limit for what we could do with this. With the alarm, obviously, we could send a frequency to, 911. We could send it to some kind of an ambulance service. We are really just looking to try and branch out as much as possible with this.
Okay. Now I'm gonna push back on that. Why wouldn't a parent just use a regular baby monitor?
The living monitor is for checking the vitals, and we want to check the oxygen. We check it before the asthma actually attacks. When it detects that the oxygen level is going lower than it's supposed to be, then we'll send the alert. The vitals will go higher if it's already suffocating. This week, while the oxygen level is decreasing.
Kind of catch it before it happens.
Is there, there's so many of those little oximeters on the market, can you use something that already exists?
So what we did research on that, and we found that it's actually too heavy for the baby. If you're going to put a clasp on a baby's toe, they might play with it, they might mess with it. So what we decided, we just said we were going to use a miniature, because it's only about half the size of this, regular oximeter with a red light. It's actually about half the size, and the thing with it is
It's light, and the heavy part will be attached to their ankle. It's the interpretive part.
Yeah.
So
the heavy stuff.
that is
if you put a sock over it too, just forget about it.
So it's comfortable to sleep in. If we were actually recommend putting a sock over it so it doesn't mess with the wire or nothing related to this. So you can just forget about it and sleep.
I think recommending putting a sock over it is cool. You might consider integrating it into the sock, so that, because kids kick stuff off.
We're open to everything.
I saw in the write-up and on the slides that there was a kind of an armband as it were to the parents. Are you suggesting that, or are you suggesting just go through their iPhone and their watch?
At the beginning, the iPhone, because everyone has a cell phone.
Yeah.
But we want to give the option to give to, like, if the person doesn't have a watch, for example, have a band, they'll vibrate and alert.
So auditory and physical.
Okay. So that kind of doubles the scope of your project, right? Which maybe you start smaller.
Yeah, initially we think on the application for like cell phones, smartwatches, and connecting to like
any alarm with Bluetooth.
Yeah, and you can
Exactly.
we want to integrate it in your life.
Okay. And do you have thoughts about cost? And who's going to pay?
Well, we don't know who's going to pay. Obviously, we haven't really gotten any connections to any suppliers, but we did some research.
Yeah, the current tow oximeters in the market are around 130, and we're estimating another 100 for the ankle monitor. That would send a message to the parents, but we're not 100% sure on that. We're just estimating around 150 to 250.
Okay.
So there are tow oximeters that exist?
You meant to say oximeters.
Okay.
Yeah, oximeters in general. Yeah.
Yeah. Do you guys look at patenting this?
Yeah, we are open to it. We just gotta do a little bit more research.
It sounds like, if there's nothing out there, that sounds like a great opportunity.
Thank you.
There's nothing specific for children.
Because children can't use an inhaler.
Most people, they use, watches, they just can check the oximeter on their wrist, but it's not as precise as your fingers or your toes. That's why we chose the toe, and it's better to sleep, so.
Are there oximeters that are already wirelessly connected Bluetooth Wi-Fi?
there are, but it's specific for adults.
Okay.
Would you be able to use this, I mean, in general, right, if you're measuring blood oxygen, would you be able to help like any child that has any other issue, right?
Yeah, so that's the thing with this. That's what I really like about this idea is that sky's the limit. You know, this could be used for sleep apnea, it could be used for many different problems. So
Parents would just buy it, just
Yeah.
put it on their feet, just so
Yeah.
that they know if something's going wrong. And-
yeah.
Good.
Okay, we will circle back to Phil Mill. Ready to come up? Yeah, it works.
Hello, we are Phil Mill, and I want to talk to you today about our horrible recycling rates. How do I switch it? In short, recycling is not going well. Did you know the national recycling rate is only 4.47%? That's horrible in a world that's striving for sustainability. And we looked into this, and we found that the biggest reasons for this low recycling rate is the lack of access to everyone. Not every single town has a recycling program available to them, and not everyone is able to easily throw away their recycling, such as at Seoul. We have fuel bins, but not everyone has that convenience. And this leads to low participation rates. Any sort of friction that consumers have ends up, it just lets them throw away their recycle. They're like, this is too inconvenient, so I'm just gonna throw it away. Or they just don't do those second thoughts. And third is dirty recycle. In Lowell, you actually aren't able to recycle anything that is dirty. If you think it's dirty, they just say, throw it away. A lot of these problems come from a policy instated by China in 2017. Now, in 2017, China was importing nearly 50% of the world's recycling. And with this policy, they set a limit on acceptable contamination, and they lowered it from 10% down to 0.5%. This lowered their imports by 99%, which had huge problems all over the world. And not only that, their policy influenced other countries that were importing a lot to also put in these same policies of eliminating the contamination.
Now, the problem that we face with this is that since China is not accepting our post-consumer plastics, we're resorting to other forms of recycling like landfill, which isn't good for our environment. And this can go back into our ecosystem through microplastics because these landfills don't have barriers that keep these microplastics from moving from storm, wind, or falling back in the ocean or an animal eating them. And so we say, why can't we burn them? But when you say burn a polymer like PVC, that makes hydrochloric acid go in the air, and from what I know, that is bad. And move on.
So as you were saying, because of China's new policy, we had to change everything. So now Boston, they used to pay only $2,000, pay more than $5 million a year, as we cannot export our plastics to be recycled. And we have a problem with the landfills, as he was saying, because it doesn't affect only the environment, but also the animals and the humans around. And we also have increase of emissions in burnways of CO2, and it's very unsustainable for us.
This here's our data on recycling rates in the USA. And so from all right now today, the United States is generating 35 million tons of plastic waste, and only 4.47 of that has been recycled. And through this graph right here, you notice that plastic recycling, that yellow line, isn't very high up, and it should be, considering that we have much more plastics production on the rise, and the recycling rate is dormant. And here we notice that from 2000 to 2018, the tons of plastic doubled. And here we can recognize that it's really just taking home that there is a market for this gap in plastic production rising and recycling not happening. So our final business model is about giving a more user-friendly resource to recycling for hobbyists or companies that are looking to recycle their polymers.
So in the market, there are a few people also doing similar things. We found one company, they are selling a recycled PVC filament. And the thing is that they aren't incentivizing anyone to recycle, they're just selling recycled products. Another company, they build machines to recycle, but the problem with them is that these are expensive machines. They are not easily accessible. And most people will not be able to use them, so they don't have access to it. And as for the DIY market, there are a few solutions. There's a lot of projects online that have ways to turn your plastic into something useful, such as 3D printed filament. But what none of these do is they're very inconsistent designs. There's a lot of manual labor going into building them, and you might not get a consistent product. So our solution is to build a certain kind of product that incentivizes people to recycle. We're building a machine that allows people to recycle their own materials at home into a 3D printer filament, and we will also be selling that machine to anyone who wants to do the same. They can build it at home. It'll be an open source project. We will be using that machine also for our own business model, where we will sell 3D printer filaments, and we will offer a discount to people who bring us their their recyclable materials to turn into.
Well, real quick, if we had more time, which unfortunately we did not, we wanted to create, I'm sorry, I know I'm going into your time. We wanted to create an open source solution where we want to sell. We can't keep going?
Yeah.
Okay. Tragic.
Friday.
But that's okay, because we have pictures of it.
So, how much of the plastic out there is actually recyclable? And do you think your users would be trained enough to identify what could be recycled and what couldn't be recycled?
Globally, 9% of all plastics are recycled. And for right now, we are experimenting only with polyethylene terephthalate, which is what most water bottles are made out of. And so PET is also one of the most recyclable polymers. And so right now, I think a big marketing market is just we're using water bottles, and a lot of people have plastic water bottles in their house. So I think that application could be easily interpreted into our model.
Also, it is already labeled on. They have little triangles on them and they have numbers, so we can put little charts with our product that to help users identify it.
So I'm going to ask, so your business model would be people will bring their PET to you to use, and you recycle it and create filament from it and sell it to them.
Yeah, we will be taking consumers. We will allow a drop-off center, and then people can bring us their recyclable material, and we'll use that to make filaments. And we'll offer discounts proportional to how much they bring us. But we'll also be sourcing our own.
Okay, so how big do you think the market is for people who want to buy 3D filament to come to you for their PET filament versus buying it online for heavy?
I think the market's pretty big because the 3D printing industry is just growing every single day. 3D printers are getting cheaper. You can buy one for $100 on sale now. And maybe they might not want to spend a ton on filaments. Our incentive of buying it is it's cheaper. It should undercut the market for normal filaments. Our normal roll costs around $20 to $30. We're shooting around like $10 to $20, accounting for the fact that it's a recycled material.
You shouldn't sell it for $10, or that would be your cost?
It would be cheaper than that, so say, because the recycling is sourced from something cost effective, like partnering with the school system and trying to use their recycling. Cheaply sourced methods.
Are 3D printers using PET now?
You can definitely buy PET, but usually that is made from virgin plastics. Like I said, there was one company that was selling recycled materials. But we did send out a survey, and most people have never used PET to print, but doing a little bit of research into it is not that much more difficult than just putting your printer and tweaking a few settings like the temperature or the flow rate.
What about drying the material and so forth before you use it? You have to dry it.
From the machine, it should be just ready to use, but if you leave it sitting out, it will absorb moisture.
feel like you could make this filament at a lower cost than the folks who are making filament today?
Yeah, especially since we are sourcing recycled materials and also looking to into the community and maybe partnering with towns or schools to use their already in place recycling programs and just sourcing it from that, which should be very low cost if not very.
Yeah, I'm sure that we give it to you. It's the cost of going there, finding it, getting it, bringing it back.
Yeah, and also we talked with the makerspace a little bit, and they're like, this would be great if we just took the scrap 3D prints and then just turned it into new PLA that we could use. We go through the same machine.
I know you guys have run out of time, but do you have an idea what this machine is going to cost? And you're saying people can build their own?
Yeah, so the competition had really expensive things, so we're trying to undercut that. For the other extruders, they were like $5,000 in parts, but we're trying to target around $500 to $1,000.
And this one, what competitive advantage does your product give you versus that company that's currently PET recycling?
Okay, so I guess it's less of why we want to come into industry and be the best filament on the market and more of what we're trying to do to help the environment. So we're trying to take these plastics that are otherwise going to landfills getting burned, and we're creating something useful out of them. So we may not be the most expensive, the best filament on the market, but we want to produce filament that'll be consistent and it'll work the same as PLA, PETG, anything else on the market. Just at a cheaper cost and incentivize recycling at the same time.
And next we have pack strap.
Hi, I'm Meredith Citrone. This is Katie McDonough, Matthias Kantor, and Paul Donahue, and we are passionate. So the problem we chose to address was bad body posture and back pain. Specifically, we found that back pain was the leading orthopedic problem in the world. So we took this and kind of ran with it specifically to students. So we found that the cause of back pain in students was wearing a backpack. The backpack weighing on the shoulders was causing bad body posture, which was leading down the road was causing the back pain.
Alright, so the backpack market currently started in 2021 was about 11.07 billion, which was in a bit of a lull because of COVID. So by about 2029, it should be up to 30 billion. But due to the ability of our strap to attach to other bags and the fact that it comes separately makes it stand out from the competitors. And it shouldn't be able to anyone who's worried about their back health, anyone who uses a bag, who is a student, or just uses a bag in general. But through the ability to add different designs to the strap, we should be able to appeal to all age groups and all denominations.
Okay, so our solution for this is we made a strap. We made a strap that can be added on to any backpack you own, and it goes around the waist, kind of like a hiking backpack, but it's an add-on that you can add to your backpack, and it's more affordable for students, especially because, as a lot of people in this room know, students don't have extra money to spend. It basically takes the weight off of the shoulders as much as possible and centralizes it on the waist, creating better posture and in turn helping the back pain that that person has.
So with our product, the biggest piece of criticism we've gotten is that a lot of people say, oh, I've seen this on my bag. I have a strap on my bag. But the biggest difference from ours that puts it apart from our competitors is that ours is on the bottom of the bag. most backpacks for students for just general use, if you see a strap at all, it's going to be on the top, the sternum strap. That strap is more so for posture. It allows for better posture when walking around carrying a heavy load. But with ours being on the bottom, as Kate is demonstrating, ours is more focused on weight distribution rather than posture. So yes, it will help improve posture, but by distributing the weight off the shoulders and spine and onto the hips, the torso region, and it's still trying to distribute it more equally, so it's not weighing just on one part of the back. We hope to prevent back pain from developing. So one of the key people we want to target with our product is children specifically, young children. We oftentimes see them walking around with giant bags the size of them that they can't even begin to carry. So we hope by having this strap for them, they can start wearing it at a young age, which they'll then continue to wear throughout the rest of their life, as we hope, and that will prevent the back pain from ever developing. And a way we want to make this more exciting, fun for the children is by doing different designs, different patterns, something that will interest them, make them want to buy our product. As we saw recently with COVID, with masks, a lot of people, children in schools, they didn't want to wear their masks, but by having those designs, it made it more fun and appealing to them to just get it done. Because obviously, you don't want to wear it, but if it has to be done, and if it's for your health, we want the children to be doing it. One other thing about our bag that we hope is another part that makes it stand out is that it's the add-on feature, as mentioned earlier. By having it add on to the bag, rather than having to buy an existing bag with this strap, which isn't often out there other than in a hiking backpack, which serves a different purpose, we hope that it'll be a cheaper, more sustainable option for people. And
how do you attach it? It's critical where you attach it, I assume, right? And how would you attach it?
Okay, so on the bottom here, it's attached to the strap. So this side is by Velcro, because we were thinking, we kind of tested out a few different things. Industrial grade Velcro is very, very strong. You wouldn't expect it to be because it's Velcro, but it can get the job done. And this side, we actually use the buckle loop to strap into this strap that comes just on pretty much every backpack. And then this goes around the waist and clips in here. And it can be adjusted to any size.
If you don't attach it to the backpack itself, then how are you taking the weight off of the person's shoulders?
So because it's the add-on, it needs to attach to the backpack strap specifically at the very bottom.
Okay.
And there's an extra piece here that goes across the back of the backpack, and that basically just kind of makes sure that these don't slide up, and kind of defeat the purpose of it.
I think that's, so those are tricky challenges to make sure that across all of these different backpack designs that you can mount it in the right way. My main question is that I see non-compliance from at all ages, like people will throw one, it's not cool to put two straps on, they put one strap on, or right, this is prevalent everywhere. What portion of kids would you expect to be compliant with this, to put two straps over their shoulders and put this belt on?
yeah, exactly. So we did find for sure, you see, not everyone wears a backpack properly, and we know that that will not be happening. We hope though with our product, if you care about your back, if you care about your health, you will be willing to do this. We want to make it as comfortable as possible. With my research, we hope to find the best way to attach it to different materials we could use. And by doing those different types of designs, it can apply to, all demographics. Children with different patterns, if, just a college student doesn't want to stand out with a weird looking strap, of course. So we hope to just do, solid patterns, something that would blend in, something that would be comfortable and practical.
something to kind of go off of that is I know a lot of people my age care about the name brands and things like that, so they don't want to buy a whole new backpack. They want to keep their Nike brand, Supreme, whatever they want. And so that's why the add-on can be very useful, especially with my backpack, it matches the color of it, so it's very incognito, and you can add it to whatever you really want.
So what's your next steps after generating the prototype here? How you experiment with it? What are your follow-on activities that will improve your solution?
Yeah, so first and foremost, our first thing we want to do is more research. This is, it's very new. We want to get more information, raw data, because so far all we have is more so just surveys from people we've asked, oh, is this something you'd be interested in? So we want to actually get more statistics on weight distribution, how much it actually distributes. We would like to see, how are people wearing it? Is there a way we can make it better? So first and foremost, definitely more research, more finding out what works best.
So to add on to that one, we're in the perfect place for the research as well. We're at a college, we have resources in all the labs and the maker spaces, and we also have a perfect pool of data here. Faculty that wear their backpacks, all the students that wear their backpacks. So there's plenty of places to go to get the data that we need to go further with this project.
Taking your way. So, Rhea Band.
Hi, so my name's Alexa. My name is Vanessa.
I'm Tim.
And Arden.
So our project is the rehab band. So our problem is that rotator cuff injuries, which are a tear in the tendon on the shoulder, can lead to a period of disuse because when you get this injury, you're unable to move your arm more than 90 degrees upwards or to the side, which can limit your range of motion. And then to fix these types of injuries, you need to undergo surgery. After the surgery, you'll be in a sling for a few weeks, which will also extend the period of disuse. During this time of disuse, your muscle is not being used, which is going to cause muscle atrophy. Muscle atrophy is a decrease in the size and strength of the muscle, and the type of atrophy is directly related to the severity of the injury. So the more severe the injury, the more atrophy, and this can go up to 75% of the original cross-sectional area of the muscle. And these types of injuries affect about 30% of the adult population, so there is a large amount of people who are affected by this. So we're also going to be looking at more of a younger population, but this can be worn by anyone because after the age of 35, you have a natural muscle decay. So we're going to be kind of looking at people who aren't experiencing this yet or have just started to because it'll have a better chance of building their muscle back.
So physical therapy equipment is in high demand. The market is supposed to grow about more as 19 billion by the year 2030, and 80% of our population today find their medical equipment and medical products online. Therefore, we also would like to have this accessible online as well as able in drugstores such as CVS.
So one of the things that made us want to do this is someone I know has a rotator cuff injury right now. He's unable to lift his arm more than 90 degrees, like I said earlier, and he's already noticed a decrease in muscle mass in his bicep and even in the deltoid region. And he hasn't undergone surgery yet, but he will. And he's definitely like, this product would be something he would want to buy.
So the market for this product, since there's such a demand in the if you look online, some of these devices that are targeting this type of injuries are over $300 right now. So we wanted to make something that it was affordable and accessible to most people. We actually was able to put this device together for under the $100, making it only like $68. That's all we spent. So we haven't really think of a market price, but we wanted to keep it under the $100.
So for our solution, we do utilize resistance bands, which most people think of resistance bands thinking of more as just very light workout. This actually proven that muscle recovery and growth with resistance bands being used consistently it's very comparable and similar to if you're using weightlifting or body exercises a couple times a week. So it's a little bit different because with this, it does exercise both the biceps and triceps, and it's interchangeable between arms, so you're able to use it whichever arm is necessary. And as you grow your strength with it, it's fully adjustable, and hopefully in the future we will be able to interchange it with other strengths of resistance bands.
So what we used is we got the shoulder strap off of Amazon, the structural support. Then we used resistance bands and a backpack type strap to clip the resistance band into here. We 3D printed screws. This might not be good for long term, but for short initial prototype, this is how it was connected. Then we used a simple lifting strap on the wrist and tied the bands there. So when the bicep is contracted, the band in the back, it provides resistance. And when the tricep is contracted by straightening the arm, the band in the front provides resistance. That way both the bicep and tricep are doing work at the same time with the same product.
You mentioned that you can increase the resistance and decrease it. You know the force can be adjusted for the force.
Not exactly that.
We don't know like the specific like.
You haven't calculated that, how much force it would take.
No, we do not, but we do have like. Yeah, we can tighten it, loosen it, however we see fit.
And in the future, we would hope to be able to change out the band so that right now this is a light resistance band, but you can interchange it with medium and higher strength so that depending on your needs and how much you need to grow your muscle back, you can interchange them.
So you're not fixing the rotator cuff?
No, so this is after. So after you have surgery and after your rotator cuff injury is healing, you're able to do this to build back the muscle that you lost during the time of the injury.
This would hopefully drastically reduce the recovery time
Yes.
to have your muscle strength back to where it was.
But you're really building bicep and tricep, you're not building the
So
shoulder.
as of right now, that's what we're thinking of. In the future, we want to expand on this and add a strap around the waist that can actually go under here, so you can go like this, and it'll work out the tricep, deltoid muscle as well. So this is kind of just our first step, but we definitely want to expand on this and target more muscles in the region.
Have you spoken to any physical therapists in regards to if there's any products out in the market similar to this, or are they using any resistant bands currently in their rehabs?
We haven't spoken to any physical therapists, but we have done some research online to see if there are any similar devices. There are some that work out individual muscles, but nothing that we've found is as versatile as this.
The black piece that you said, I think you said you bought off of Amazon?
Yes.
What was the function of that?
That is mostly just for it's just support. It's structural, so that way when you're pulling on the straps, it's not really moving across the shoulder. It's very stable.
And what's Amazon selling that for? What is the market for that black thing?
It was the most expensive piece.
I think it was under $30.
Yeah, but why is Amazon selling it? That's what he wants to know.
Oh, it's just for support. So if someone has a back injury, it kind of just, there is a strap that goes in the front.
They just took out
so
the
it kind of
straps.
just supports your back too.
Okay.
Yeah. So we just kind of, repurposed it.
last but not least, physical engineers.
We all ready to start? All right. My name is Kyle Callahan.
I'm Alex Johnston.
Our group is the Physical Engineers, and my colleague Alex is going to get us started with the problem.
Okay, so in the healthcare industry, there is a commonly used transfer technique known as the log roll technique. Basically, this is just used as a method of transferring patients who have spinal injuries between different positions. However, it's commonly used, but however, recent research shows that it can actually be detrimental because it doesn't fully prevent motion in the spine. So this is our problem.
All right. So current research shows that about 250 to 500,000 people suffer spinal cord injury each year. 17,000 alone in the United States of America. Furthermore, 37 in every 100,000 people will experience a pelvic fracture statistically. The first article we observed was a case study of a pelvic fracture in which the patient was transferred with the log roll method without our device, of course, and that actually resulted in significant movement, which caused hemorrhaging at the site of the fracture, and the patient actually had to be sent to the ICU to recover. Two more additional articles, both done by the same group of researchers, analyzed the movement of the spinal cord during the log roll transfer in both the cervical region and the thoracic lumbar region of the spinal cord, both respectively. Both articles concluded that there is a significant amount of movement in the spinal cord during the log roll transfer. Last article, we observed compared the log roll transfer to other types of transfers that we see in the healthcare field, for example, sliding someone onto a spinal board. They singled out the log roll as ineffective and very compromising to spinal integrity. So, as far as competitors, we don't see any products to our knowledge that resemble ours in any way. There are various products such as a mat in a hospital with handles, gait belts, spinal boards, which are all far more expensive than our product, but do not focus on the log roll maneuver specifically or focus on preserving spinal stability. Of course, the spinal board does that, but you need something to preserve spinal stability while transferring on and off the board. Our solution is the device you see right here. That is our visual model. We call it the log roll handle. It's a device that kind of resembles a handle in a way. As you can see on the presentation, that is a 3D model device that was constructed in SolidWorks.
Okay, so this is our first prototype, but like I mentioned, we did create a 3D model in SolidWorks using the sheet metal package. So as of right now, we don't have a quote to see how much it would cost to get a unit manufactured, but we do have some price points of the different types of attachments that we're going to put on our device, which is included here. So the total cost for all the different attachments will be $40, and then in addition to that, we're going to have to find out how much it would cost to build a sheet metal base.
So to conclude really quick, the device has 3 points of contact, one bar across the sternum, another the pelvis, one runs actually under the knee. You would be shocked at how easy it is when that device is on a patient to just turn them to the side. With a grant, we can conduct further research with the metal prototype, which can actually support a human's body weight, that'll prove the preservation of spinal integrity. But I believe that this product does have a home as is, as it makes the log roll far more efficient and safer for both the professional providing the transfer and the patient. and take questions.
I was wondering if we get some visual on how it works. Yeah.
Yeah, I think we're ready for a demonstration. We are on stage. All right, so like I said, there's gonna be 3 points of contact, one on my sternum, one on my pelvis, and then another bar is gonna go under my knees, and you will see, it might take me a minute to get this right, but you will see how easily Alex can roll me on my side.
So I would just grab the center of the bar and apply some pressure, and I'm able to easily turn Kyle over onto his side with very little effort.
And if I may add something, from that position I was just in, a healthcare provider could grab the bar that was across the sternum as a handle and easily lift the patient, if they were in a hospital bed, to an upright sitting position from there. Physical therapists say perform standing treatments without expending any extra energy, moving from a lying position to a seated upright position.
Would you have to be, no, if you were unconscious, you couldn't do that.
I'm very glad you asked. It was not covered in the presentation, but we do intend to have gait belt attachments on the part that goes around your sternum and then the part of the pelvis. Gait belt, if you're not familiar with it, is a very tacky belt. It's going to go around the clothes. It's not going to slip inside on the clothes. It's going to keep you very secure. We have a feeling that this is going to contribute greatly to preserving spinal integrity through the log roll. And of course, if the patient is unconscious, this will account for not being able to hug the bar.
So you won't need a strap, you don't think you'll need a strap?
Yes, the gait belt will function more or less as a strap if it goes around the sternum and the pelvis. It's a belt strap per se. Think of it as a strap that is very secure and won't slip and slide up and down the clothes.
So the gait belt's going around behind your back, up and over?
Yes,
Okay.
around the chest, essentially.
So there's some manipulation that happens in this process. How do you know the mechanics of that manipulation are better than a log roll?
Well, that we would need a grant to conduct research for, and we will model our research after the 2 articles that I showed earlier that initially disproved the log roll without our device, and we're able to look at spinal cord stability throughout the maneuver without our device. We would kind of model their research and incorporate our device and see how it improves their transfer.
So you've got a hypothesis that this will reduce the motion, spinal motion, right?
Yes, at the moment. We can't prove exactly how stable the spinal cord is.
Why do you think that, what's your hypothesis based on? Is it just intuition or is it?
Intuition. We believe that the 3 points of contact, one going across the sternum, the pelvis, and under the knees will provide a significant amount of stability, certainly based off of how easily he was able to move me in that position. And at that, if research proves that this is in fact not safe or even detrimental to the spine, I think this has a home in every hospital bed at the moment, as it can make healthcare providers' lives far more efficient and not let them compromise their biomechanics when performing the log roll and transferring patients.
I love the application of that's not spinal related as well. And there could be a ton of opportunity there.
So great job by all the teams. So there's still a chance to win the People's Award, so please stick around for that. Additionally, please apply your idea to the Spring's 2023 50,000 Idea Challenge. Applications for that opened up yesterday, and the judges are now excused to do their deliberations with respect to how these presentations went today. So we'll now have a 30-minute intermission. Enjoy the snacks that we have back here. So let's get on with the awards. So I do want to share this advice with all of our teams that competed this evening. If you recall, I talked about one of the teams from a previous year, the physical therapy team that has these tiles that they put on the floor, that they can replicate the different terrain inside the house as to what it's like outside. I want you to know that the first year that they competed in this, we kind of looked at it, it's like, yeah, they got these little tiles. And so they didn't get a prize the first year that they competed, but they came back. And they won a competition, they got an award, and now they're going on and turning it into a business and having a patent. So what I'm trying to say is, if you don't get an award tonight, don't be discouraged. We really want you to come back and try again. There's the Spring Idea Challenge, and as I mentioned earlier, sign up for that opened up yesterday. So I'd encourage you, maybe get a good night's sleep tonight, but tomorrow morning, go ahead and sign up and get ready for that next round.
All of them should.
All of them, yes. Yes, the judges were very impressed, this round of judges, as well as the previous, the preliminary judges. So don't give up yet, keep on pushing. So it is now my pleasure and my honor to announce the awards. So in third place, oh, the people. Let's do an instant replay here. My notes here have People's Award last.
Oh,
We'll do People's
you can do
Award.
what you want.
So People's Award is Project Poseidon. How does this work with this?
So if you guys come out of that one,
Yeah.
I can actually get rid of it. Without calling. You know what? Can you let people come down here?
Yeah.
I think she's all false.
That'd be awesome. We'll do this one. Are you in there?
Sure.
Awesome, we'll do a couple. Thank you so much.
Thank you. Congratulations, Scott. Thank you. Okay, in third place, Rehab Band.
Welcome. Let's go up. You can go up.
You want to get a picture?
I got it.
I don't want to miss a chance to get my picture taken. Second place, Solar Sales.
Good job.
And in first place, Catnap. There are steps here.
Congratulations. You're welcome. Thanks so much.
Okay, so great job to all the teams and to our judges. Thank you very much once again for your service. Paulette and Dave, they'll follow up with the teams on next steps now that you have these awards. Thanks to everyone for coming this evening. Have a good night. Stay well.